All right. So, hello and welcome to Kansas City SQL Server User Group. Glad you could join us for our Lunch and Learn with Edward Pollack, presenting parameter sniffing and everything you have been told is wrong. That title alone had me super intrigued. So, well done. Well done. For the audience, this session is recorded and will be uploaded to our YouTube channel. Once the recording is ready, I will place the link inside the meetup event. QAs will be live throughout the session, so feel free to ask, and I will hand those over to Ed. And with that, since this is a lunch and learn, we will jump right into it, and I will hand it over to you, Ed.
All right. Well, thank you very much for having me. I appreciate it. I do have a soft spot for virtual events, and I love seeing new groups start. So thank you very much for putting all the time and effort into this. It's awesome. So I'll dive right in. We have an hour, and squeezing this into an hour may be challenging, but I will do the best I can without talking too fast. So this is a topic that I believe is timeless. It never goes away. We've all tried to make it go away. Microsoft's tried to make parameter sniffing go away, and it doesn't. It still doesn't. Even in 2022, with all the patches, hotfixes, CUs, and everything, it's not gone yet. And better yet, all the tools that we love to lean on to solve our problems, like OpenAI and ChatGPT and other kind of cool things like that, they don't solve this for us either. So this really is going to be a presentation that includes just a lot of tips and tricks to try to solve these problems on our own, so we understand how they work, and then we can eventually use tools and other things to kind of make our lives easier. So it really is just timeless. This never goes away. This is me. I've done a whole lot of stuff in the data platform world. I'm a data platform MVP. I organize a handful of events. I've written some books. I do a lot of speaking, so I'm busy. I like doing this and sharing. If anyone here has any questions after this is over, feel free to look me up and just connect with me and ask away. But otherwise, this is who I am, and that's enough about me. Our agenda is basically to quickly review a lot of things about how the query optimizer works, how plan reuse works, what sniffing even is, what is it, and then move on to how do we resolve it? What does it look like? And not a lot of what we talk about here is not going to be stuff you'll find on Stack Overflow or all over the internet sitting around. And some of these are the hard truths that sometimes the code we write is stinky and we got to deal with it. But we're going to go through all of that and have the most fun we can along the way. If you have any questions, I can't see the chat right now, but feel free to interrupt me and I'll take a few deep breaths and answer them. To start out, the most basic conversation to get this going is how is the query processed? And in SQL Server and in most engines, there's a handful of steps. The first two in the SQL Server world are parsing and binding. Parsing checks syntax, keywords, things like that to make sure you wrote a query where everything is spelled correctly. It's really just making sure that you spelled select right or where, or you didn't forget a space or something like that. So very, very basic syntax checking. If you made a mistake in your query, you'll know it right away. You'll get a big red error message pop up immediately telling you messed up and you fix it. SQL Server has gone past the parsing section of the process. It goes to binding. Bindings where it now checks all the objects you referenced, views, tables, stored procs, columns, whatever, and makes sure they're real, they exist, they're valid, the data types are correct and all that stuff. That, again, if you make a mistake here, you'll get an error pretty quickly before your query even runs because you made a mistake. It'll be a different kind of error, but it'll tell you your object doesn't exist most likely to figure it out, or a wrong data type or something like that. So parsing and binding are what happened initially, and it really is just there to make sure that you're doing the right things, and that your query can be processed. If it can't be processed, we can't go any further. The section this whole presentation is really about is optimization. And so SQL Server's got to build a query execution plan for your query somehow, and it's complicated. It doesn't always sound complicated, but it is. It's a huge amount of complexity in the software underneath the covers to turn your query into a set of instructions to run against the objects that are out there to get the data back that you need. And there's many ways to do it. And the more complex your query, the more possible ways there are to get your data, and also the more possible ways there are to get it the wrong way. So it really is like a going through a whole bunch of different options for how to optimize the query, how to run it, and then assign cost to them, and eventually pick the one that has the lowest cost and use it. And the output of that's an execution plan. And note that when I say do all this work, it's doing it sub-second usually, very, very quickly, but it's CPU intensive, very CPU intensive. So optimizing a query is not trivial, it's not cheap, but it's very, very important, and it must happen fast. If it takes a minute to optimize a query that takes 1 second to run, we've clearly failed. Can't have that. And then last but not least, once you have an execution plan, The execution engine just does those instructions. Whatever the instructions say to do, it does them. It reads tables, joins data sets, sorts things, whatever, and the results come back. You're done. We're going to focus on optimization for the sake of this presentation. An execution pen looks kind of like this. You've probably seen them before. It's really just a set of instructions describing how to read or write data. How do you get the data you need from storage into memory, filter it, sort it, do whatever you got to do, and then get it back to where you have to get it when you're done. Each step's an operator, and it goes from right to left. So it's kind of the opposite of how we write, unless you live in a few countries that go right to left. But in general, you start on the right with your table reads and object reads, and you move towards the left where the final operator is a single, select, update, whatever. And the optimizer has this complicated process. I kind of spoke about it a little bit already. It's important to note that just because the optimizer picks a plan does not mean it's the best plan. It tries. It's a really good piece of software. It's an amazing piece of software. The people who built it will stand behind until the day they die, but it isn't perfect, and it can't be perfect because you have this sub-second amount of time to generate a plan. And if I wrote some wild query with 30 tables and 100 joins and all kinds of weird predicates, getting the best possible plan may not be easy, but it doesn't have to get the best plan. It only needs to get the good enough plan, right? If the good enough plan runs in 0.1 seconds and doesn't use a lot of resources, that's great. That's awesome. Imagine how an AI in a video game or a chess program will try to pick the best moves. It's very similar to that. It's going to go behind the scenes grinding away at all those moves to try to pick the best one, and it'll try to pick the best one. If you've played chess versus a computer before, you know that it may not always pick the best one, and to get a better one requires more time, sometimes a whole lot of time. But for now, most important takeaway is the plan chosen may not be the best plan. The more complex your query, the more complex the plan. So real quick demo, just really to help us because we haven't seen it before, very, very quickly. We're just going to use demo database because for the purposes of this, that is fine. We're going to turn on the actual execution plan so that when we run our queries, we'll get an execution plan back to look at. If I run a simple query with a simple filter, I get back my 81 rows. It's pretty fast. I also have statistics IO on. So I can I see the IO of my query right here, logical physical reads. And I also have an execution plan that I can look at that shows me a seek, a lookup, nested loops, done. Very simple query, very simple plan, but I really just want to demo quickly what it is we're talking about and how to see it. There are other ways to see it as well. You can view it in the plan cache. You can view it through extended events. You can see the plan XML. There's many, many ways to see this kind of information. I will demo a few other ways soon, but not right now. As I mentioned before, optimizing a query execution plan and generating that plan is expensive. It requires a lot of CPU. It takes time. And if you have a busy server with millions of queries executing, if we did that all the time for every query, you'd use a lot of resources. You would really burn a lot of compute, and really you're wasting it. So SQL Server and most relational engines have a cache. And so plans get cached. And when they get cached, we save them for later. The way it works is your execution plan is generated for each query that's executed based on its exact text. That means if you change the text at all of the query, your execution plan will get a new execution plan for the query. It can be the same plan over and over, but if your query changes, the execution plan changes. If I simply capitalize the letter in the query, I get a new plan. The good news is that once a query is run and the plan is already in memory, there's no need to optimize. SQL Server simply says, oh yeah, that query hash is already here, the plan hash is here, just go ahead and use the plan we already have, we're done. And that's extremely fast and efficient, requires very minimal resources. And that's what we want. This is a feature. Because the plan cache is in memory, it's fast. If you restart the server or run any special commands, they'll get cleared. So when you restart the computer or clear the plan cache, things may be a little slow for a bit as execution plans are created all over again. Plans can age out due to time, due to changes in objects, due to memory pressure. If you have memory problems, you may find that plans age out really fast, and that's not good. Everything we've talked about so far is managed by SQL Server automatically. You don't have to do anything. It simply does this in the background, which is good. Again, you don't want to be managing this as a human being. Trying to manage this manually would be complicated, difficult, error-prone. Realistically, we as database people are going to not be better than the optimizer 99% of the time. Once in a while, we may have good ideas when things are slow, but most of the time, the optimizer is pretty smart and we should rely on it until bad things happen to happen. And we'll get there later as well when bad things happen, right? The whole presentation here is when bad things happen, right? And who's at fault? First off, you may have seen this before, dbcc free proc cache. I will use this here to clear the entire plan cache on my local server. Don't do this in production, please, never, because you will now clear out all your plans and every query is going to require a new plan. You're going to make your CPU go like this, and things are going to slow down and go like this. And the clients and people using your server may not appreciate that. So please don't run this in production, but on your local server testing, on dev, QA, whatever, have a blast. But just keep in mind this is noisy. It'll impact everyone else on the server aside from you. Right now on my local server, named after a Pokemon, so no one else is on it, and that's great. All my servers named after Pokemon. That's just how it is. We all get a laugh out of it. If we're more specific and not blow it away for everybody, you can simply clear the cache for one DB ID. For example, I can pick the current one and do this. It's a little less noisy. I'm now just clearing the cache for one database, but still something you really shouldn't do in production unless you truly, truly mean it. So what we can do here now is run a query, and I'm going to share all this stuff later, by the way. I don't feel the need to type really fast or anything right now. To summarize what this query does, it goes out and it gets information about query stats that tell us some details of how queries execute, the SQL text of the queries that execute, the execution plan, the text of the plan, and then I can do a little bit of filtering. The text lets me filter. Again, I'm not going to dive into every single column here. It's not worth it. But if I were to run a query, this one right here, a simple query, and then run this big query that checks the cache for information, I can get data back. So here's the query from before that I ran, and here's what comes back from the cache. Now I just cleared the cache. It was empty. I ran a query, went to the cache, saw what's in there, and I have one thing in there. A lot of useful information. The query text, the execution counts, reads, writes, worker time. That's kind of like CPU. It's a gauge of CPU. The query plan is right there. I can click on it, the XML, and see it graphically if I want to. I can go over and see the text of the query plan and so on. So this gives me a ton of useful information. You can add or remove columns to this very, very easily. No problem. If you want more or less, whatever. You can really customize the last execution time. Very, very useful. So we're going to reuse this query a lot. Feel free to steal it from me and customize it to your own uses. I don't mind. We can now note that if I run the query with different values, this is not parameterized. So I'm going to run the query for one value, another value, an imaginary value, -1, whatever. If I were to run all these different values and then query the cache again at the end, what I'll notice is nothing. That's weird. What's going on here? Did I put too much in here? Hello. Where's my data? There we go. Okay. That was strange. I think I was clicking on the wrong thing just now. Sorry about that. But anyway, you'll note that because I ran the query with different explicit values, I got back a whole lot of different queries here in my execution plan cache. The plan cache shows a whole bunch of different queries now, all looking different. Some I executed them together, some individually, and they all went in here separately. This is kind of what we look at as cache bloat. If you don't parameterize your queries and you run them all with hard-coded literals, you fill your cache up with lots of executions like this. And this isn't really what you want because this all this is stored in the cache, your query text, your plan details, everything. And the execution plan may or may not be the same here. I suspect for all these executions, they're probably the same. Seek, lookup, nested loops, seek, lookup, nested loops, and so on, because we're all just looking for one value. So this is not really what you want to do in an application. You can do it for one-offs here and there, but if this was happening all day long, it would be painful because we're just optimizing queries all day, which isn't really efficient. So how do we fix this problem? So far, I've shown you a great feature of the plan cache and how not to use it. Isn't that great? I've shown you nothing useful so far, huh? Well, let's get a little useful then. I'll show you some useful things now. That was useful too, I promise. Parameterization really is a solution to everything I just said that wasn't quite right. Stored procedures and really any SQL that you write can be parameterized. And parameterizing it means that we reuse the same query and execution plan for a query that might have different values coming into this. This is a huge, important piece of plan. This is actually how plans are reused. If it's not literally the same query over and over and over by text, it's got to parameterize to do it. And the beauty here is that you could run a stored proc 1,000,000 times a day, 10 million times a day, 1,000,000,000 times a day. And if it's the same proc with different parameters, it will use the same plan over and over. And your optimization, the optimizer is basically just taking a nap all day, which is good. We want that. We want the optimizer to nap and chill and take it easy and not consume all of your server's resources. That's a good thing. And so in general, we want to optimize plans as little as possible and reuse plans as much as possible. As a guideline, this will always be true. There are exceptions. That's kind of where this presentation is going, right? The exceptions. But most of the time, that is what you want. And so the exceptions to that rule should always be reviewed as exceptions and not the rule. We should never revolve our world around parameter sniffing or bad plan reuse. That's going to end us in a bad place. Let's talk about parameterization. So I have a query from before that I wrote, and I ran it over and over and over and filled up my cache with junk. Cool. Not cool, actually, very not cool. Let's clear the cache on my local machine. I'm going to make a proc for it. Again, this is very simple. I didn't make it complicated because I don't want to make it complicated yet. Simple proc, pass in a customer ID. That's my parameter, by the way. So my query is in here, and my query now has a customer ID instead of a literal value hard-coded. So I'm going to create my proc, and now I'm going to execute the proc, and maybe I'll run it a whole bunch of times, over and over and over and over and over. And I go to my plan cache, and I see the same query, the same plan. Oops, that's strange. But same plan, same query over and over and over, and it's used 21 times. That's what I want. Let's say I go in and I run it a whole bunch of different times now for one value, another value, -1, some giant value that QA made up, I don't know. And then I go ahead and I check the cache again. I go in and I see it's been run 6 more times. The same proc, the same plan, all of my metrics here have just been incremented. So I see my total worker time, my total logical reads, but only one execution plan. This is perfect. This is what I want. If this is a really critical search query being used by an app that's smashing this proc all day long, great. It's exactly what I want. So this is plan reuse. This is what we want as often as possible, is the plan cache to be small, to reuse the same plans over and over. That's ideal. All right, now we're at the part of the presentation we talk about where things go wrong. Parameter sniffing. This is where we talk. This is really just plan reuse. Sniffing is often turned into this big sickness, bad thing that should never happen, but it's really just a feature factor of plan reuse. What really happens here is that when I create an execution plan, the optimizer does, it's going to do so using the first parameter value supplied. If my parameter that I passed in was the value 1015, then that execution plan was generated for 1015. And every time it executes in the future and reuses that plan, it's reusing the plan for that same value. If any questions, by the way, feel free to interrupt, or I can talk forever. That's also cool. But that plan for the first parameter value supplied may not be best for all parameter values. Some parameter values may result in one row being returned, or 10, or 100, or 1,000,000. And because of that difference, it's possible that a different value being passed in may generate the wrong plan that is slower. This is a side effect of plan reuse. It's not a bad thing. We should not actively try to avoid all plan reuse to avoid this, but when sniffing happens, we can look into it and figure out why it's a problem and fix it. We can demo this pretty easily with the same kind of query as before. In this example, clear out my cache again. We'll create an index in this table just so I can kind of intelligently query against an index rather than scan the heck out of it all day. And I'm making a slightly different proc now. This one's going to take a start and end date. It's going to return all the orders that occurred between the start and end date. So again, pretty simple, straightforward. Just give me everything for a range of dates and done. So I can see that if I run this proc for a pretty narrow date range, my execution plan is a seek, which makes sense. I'm only returning a small number of rows. So a seek makes sense. Go in there, grab the rows I need, be done. I'll clear the cache. Let's say I run it now for a very wide range of dates for years. What happens? I get a different plan, clustered index scan. Now, we sometimes will think that scans are bad, but in this case, a scan is kind of fine. Like, we're really scanning most of the table, and realistically, scanning the whole table to get what we want is probably okay. You could make a covering index to try to make it a little faster, but SQL Server shows a scan. And that made sense here because we're returning most of the table. So that's okay. That was the right plan for that execution. Realistically, though, let's say most of the time we run it for small ranges, but then once in a while it gets run for wide ranges. Well, what happens then? Let's say I run it first for the narrow range and then the wide range. I'll see that it used a seek anyway, and it did a lot of reads. That's 140,000 reads because a seek means it's going to pick through the B tree and get all the values it needs out of there slowly. All of them, like this and 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 this over and over and over. That's why a seek isn't always as good as a scan. If I simply ran it as a scan, like this, it actually took far less reads because just scan the table and be done with it already was faster. Similarly, if I go back now and run this version, I got a table scan to return like a handful of rows. That also is not what I wanted. It was less efficient. So just kind of some interesting lessons here. Scans aren't always bad. And if you have the proc execute and get a plan, it may get reused when it isn't optimal. So that's parameter sniffing. That was my 100,000 whatever reads I just got here just now in a giant seek through all the universe to get what it needs. That wasn't ideal. Diagnosing parameter sniffing honestly isn't that hard. Solving it can be a little more challenging. The things we often look for, think about how do we know it's happening? How do we know the parameter sniffing thing is happening? How do we know it's a problem? One of the most obvious things would be inconsistencies. You have some stored proc or some code that runs, and sometimes it's fast, sometimes it's slow. You're not really sure why. That can be a symptom of plan reuse that's going bad. And you can look into that and try to figure out, okay, what's happening? What values are being passed in? What are the parameters of the execution plan? You can use the query store to try to see if there are any regressions here or reasons why it was good here and bad there. You may want to try to look for code that's running poorly sometimes, but with no schema changes. So no one's changed anything and something is suddenly slow. Well, what happened? Did the values being passed in change? Did the app change? Did something else change? What happened? If you have a stored procedure that's doing some of these things, and it's very, very complicated, lots of parameters, thousands, tens of thousands of lines of crazy spaghetti SQL, those are perfect candidates for parameter sniffing because they'll become hard to optimize. You know, giant queries with 30 tables and 50 parameters and procs that have all sorts of switches and variables and things. Branching logic, essentially, is dangerous. If you have anybody ever seen a stored procedure that has the switches in them, like is report live or is production or is demo, is design mode, things like that, that completely alter how the proc runs, that can lead to sniffing. I'm not saying don't do those things, but be aware that it can result in parameter sniffing. And if you are running into parameter sniffing, simplifying your procs may be very helpful. Maybe split them into two different procs where the demo one goes here and the prod one goes here or whatever, and get rid of the silly flag. It may run faster. And also, one additional way to know if it's sniffing, or at least think about it a bit, is you poke it with a stick. You play with it. You say, hey, let me just do some random weird stuff to this proc and this execution. Oh, hey, it's fast now. Yay, I did weird stuff and it works. Done. That's cool. Glad you fixed it. But if you poked it with a stick and it got fixed and you can't really prove out why it got faster, you may not have actually solved the problem permanently. You may have made it a temporary fix or left some time bomb for the future. So again, if you poke it and it gets better, but you're not really sure why, it might be parameter sniffing.
And we have a question from Matt Doe. He
Great.
says, I thought that logical reads refer to the number of data pages read from the buffer cache during the execution of a query. So we would want to see fewer pages read, question mark.
Correct. 100% correct. Logical reads are pages read. I hope that's what I said before, but if I misspoke, I'm sorry. And then physical reads or whatever had to come off storage first to get into memory. But yeah, hundreds of thousands of reads are definitely worse than hundreds of reads or tens of reads. So reducing that, I won't say you should always optimize based on I/O. That is not always the way to optimize everything. But typically, if you see orders of magnitudes higher or lower, that is a big difference, and it's worth looking into. But good point. Yes, the unit of measure for reads is pages, what I was showing before, and less is usually good. And one note too is that reading the whole table was like 600 and something reads, but reading it through a B tree as a seek took like hundreds of thousands. So you can make more reads against a table than there are pages in the table. And that's, of course, a red flag. If you're reading more data than there is data out there, then something's weird. All right. The rest of this whole presentation is all about how do we resolve parameter sniffing? How do you make it go away? How do you make it better? And that's huge. One note before we dive in is, are your stats up to date? This is important. It won't always be an impact, but rarely it may be. Just check this though. You don't want to go diving down the rabbit hole and spending hours and days of your life trying to figure out and solve a problem when it was really just stats all along. And an easy way to check to see if things are bad, or to first check, is auto create stats on, is auto update stats on. Typically, you just want them on. Their default's on. You probably want them on. If you turn them off, there should be a really valid reason you're turning them off for that we're not going to even begin talking about here, because there are exceptions. And part of the world of data, as we all know, is you have things that happen 99% of the times, and you have the exceptions. And we should always treat exceptions like exceptions and not as the rest of the time. So in generally speaking, you want these features on. You want these settings on. How do you check and see if there's a problem? Well, look at your execution plans and see, is the estimated versus actual similar? Did it estimate 100 rows and actual 1,000,000 rows? Or did it estimate 100 and actual 100? And being a little bit off is okay. If it's 100 versus 105, who cares? If it's 100 versus 150, who cares? If it's 100 versus 1,000,000, that could be a problem. And that could very well be a sign that your stats are way off. And as a note, you can create maintenance jobs to handle updating stats additionally if needed. You may not always need to, but you might want to. In general, execution plans that the optimizer creates are based mostly on stats. It looks to see how many distinct values there are in tables or indexes, how many rows are there, and it makes decisions based on that. And if the stats are wrong, or wrong they are, the more wrong your execution plans will be. So just check briefly and verify before you begin diving into a sniffing issue or a plan reuse issue that your stats are relatively okay. They don't have to be exact, but they shouldn't be off the orders of magnitude. And if they are, maybe just update stats first, retry your thing. Is it fast or not? And then go from there. If you update your stats and it's fast, you're done. And the rest of the presentation won't matter to you at all. You can just sign off right now. Don't do that, though. Stick around, please. There's more. There's more. It's not a presentation about stats. It's a presentation on sniffing. Now we're going to talk about some of the ways people solve sniffing. And you'll find that many of these are bad ideas. You may have done some of these before, too. But most of these are going to be bad ideas, and I want to point them out explicitly because they're bad ideas, and we don't want to have bad ideas. But the internet spreads bad ideas. If you search Bing or Google, your favorite engine, or AI engine, or whatever, for what's the best way to solve parameter sniffing in SQL Server, I guarantee you're going to get back some really bad stuff. This is where ChatGPT fails, by the way. It does not give you good advice here because the internet doesn't give you good advice, and its data set is the internet. So your AI is only as good as your underlying data. If your underlying data stinks, then your AI stinks. That's life. So this is one of the top things recommended by Google, is redeclare your parameters locally. That way we can get rid of sniffing, right? That's not really what happens. An important note about how the optimizer works is that it has to prepare execution plans prior to runtime. There are more features today that exist that help get around that, but in general, you need an execution plan before you get to runtime. It can defer some decisions to runtime, but local variables are not known until runtime. Because of that, if you create an execution plan and it has local variables in it, it has to guess wildly. It makes a totally stupid guess at what the row count will be, the cardinality, and then it goes on with life. That stupid guess may solve your sniffing problem, but it won't solve your performance problems forever because it's a dumb guess. It's a wild guess because it can't get an exact number because it's not known until runtime what the values will be. So when you redeclare your parameters locally, what happens is you're now using an approximation. So if it works and gets fast, you got lucky. And luck is cool. I love it when I'm lucky. Lucky is great. Winning something is nice, but you don't really want to bet your career on winning the lottery. You just don't. The result of all of this is going to be kind of a cruddy plan. It'll work, maybe, but there's no guarantee that it's going to work well. So just keep that in mind. In general, making a decision like this will haunt people later. It will stop being fast in the future eventually. And when it is, someone's going to ask, why did I redeclare the parameters locally? And the answer is going to be reasons. The prior dev, I don't know, somebody did it. In general, this is a hack. Don't do this. Don't do this ever, actually. I never do this kind of thing. I know it can be a good hack to solve a problem temporarily, but it's going to cause you trouble. So here's what I'm talking about. Your start and end date being passed in. And then I go in here and I say, oh, let me just redeclare them. Start date local, end date local equals the parameters. I have now just broken plan reuse. I've made it use a dumb plan. I've made it dumb. Is what I've done. I'm going to create my new proc. And here's what happens. I run my proc for a narrow range of dates, and I get back an index scan. It's guesstimating about a third of the rows. That's a lot. So it says I'll just scan the table. Done. I know it's suggesting an index here. I don't care. It's suggesting an index. I don't really need a covering index here. You don't want to cover index everything anyway. Typically, an index on the column you want is good enough. If you need more, you need more. I'll run it in a wide range of values, and I'll get back what I want. Great. I'll run it on an imaginary set of values that returns nothing, and I still scan the table. So the lesson here is that redeclaring your variables locally will give you a plan. It may or may not be good. It'll probably be average, and it may suit your needs for the moment, but it will eventually fail you. So just don't do it. Don't do it. It's a bad idea.
I have
No.
another quick question.
Yes.
From Prashant. Is it, oh, I just lost the focus. Is it better to run update stats job regularly instead of just rely on auto update stats equals on?
My general tactic, and you can adjust how you'd like, is to rely on the auto update, the auto create. If you run into problems, create jobs. And the reason I say that is that the frequency those jobs run, is it once a day, once a week, once an hour, will really be app specific. And I don't know your app, so I can't tell you how often to run it. But I would say wait until you need it, and then feel free to create jobs. It's a pretty lightweight operation. It won't really block much or create trouble for you. But do run it off hours when people aren't relying on data heavily, because it does create workload. But how often you run it will be based on your app. So I would say do it if you need it. I wouldn't by default have it unless you think you need it, though, only because you may not, and that's okay.
We've had to do that for our data warehouse, and it was an add as needed interval of SQL jobs.
Okay. Yep. I think in most places I've worked in my life, there's been some sort of stats job, but those are on huge servers, terabytes of data, millions of requests nonstop running. So as you get bigger and bigger, you'll find you may need it more. But again, how you schedule and do it really is based on your app and how it works. I don't want to make recommendations where I don't really know your environment very well, because I don't know your environment very well, and you do. What else can we do? Here's an option that's a little different. This is not a never, this is a sometimes treat, like a cookie, sometimes treat. Option recompile. This is basically an option that you can provide in your query that will force SQL Server to make a new plan. This will not reuse any existing plans in the cache. It won't change them. It won't get rid of them. It'll simply make a brand new plan right now on the fly, use it, and be done. Gone. So it won't go in the cache. It won't use the cache. It will simply use it. This is a good solution when you have a query that doesn't run very often, but boy, does it stink. Like the report that runs once an hour or once a day that always stinks and makes bad plans. Then those bad plans muck up other queries, things like that. This is a great way to use it, is infrequent queries that are very parameter sensitive. You can use recompile, and I won't say don't do it. It's fine. It's great. But like all query hints, use caution, because optimization is expensive. And if you begin recompiling queries nonstop a million times a second, your server is going to cry. You have to give it more resources, you're going to waste compute, and it's going to cause trouble. So the real key here is you can use option recompile. It's a great feature. Don't spam it everywhere. Like all solutions, if you solve a problem, don't simply take that solution and copy paste the rest of your universe. It's a very common mistake. I worked somewhere a long time ago where somebody wanted to solve sniffing. They didn't know what to do. Things were slow. They were in trouble. And they discovered wrapping the entire contents of their proc in dynamic SQL solved it. They didn't really know why, but it did. They took every single store procedure, the exact same thing. Don't do that. When you solve one problem, don't blindly copy the solution elsewhere unless you proved out that it's a good idea, because it may not be. If your option recompile goes from once an hour to once a millisecond, your server is going to cry, and it's going to hurt. It's going to waste resources, and it's going to cost money. So just be cautious with this kind of thing. We can demo this, a good demo. So we're going to clear things out for our database here, and we're going to kind of show, we're going to run a query and look at our execution plan, our execution count. We can see here is our query and how it ran. It got a great execution. Oh, sorry, wrong thing. It got a good execution plan. Seek, lookup, great, perfect, awesome. I'm happy with that. So what was supposed to happen happened. Now let's say I go in and I immediately run the same query with a recompile. I can note the cache hasn't changed at all. But, oops, sorry. But I got back the plan I wanted, though, and I ran the query. So if I run it with recompile, it will create a brand new plan, no matter what the parameters are, and be done. It gave me the correct plan. It doesn't matter, what it is. I can go over here and comment this out, do a scan of the table, and now it scans the table because, um, I'm scanning the table. So recompile will always generate a brand new execution plan no matter what, and that change will not show up in the cache. So again, this is a good solution for queries where they don't run very often and they're very parameter sensitive and bad plans happen a lot, or they pollute the cache with bad plans. But again, you don't want option recompile running constantly. You want it running infrequently. It's really the ideal way to use it. So this is a sometimes treat, but it's a good one that is useful sometimes. Here's what I mentioned earlier. This is a fun one. I never knew I never knew this was even something people would think to do until I saw it in production one day and I asked, why is this happening? Why did you do this? And they're like, oh yeah, I made it fast. It was great. Like I would have never thought, I wrote a whole book in dynamic SQL. This is reality. And I never would have thought to do this. So clearly somebody was very creative, solved a problem, was really excited and happy, put it in the internet. Now everyone tries it. This is like number 3 in ChatGPT, by the way. Don't do this. So what people will do is they will take the query and rewrite it in dynamic SQL, splicing in the variables. What this is really doing is turning a parameterized query into a literal query. So you're back to the beginning where you generate a different plan for every value. This will avoid all plan reuse pretty much for different parameter values. Now, yeah, you'll reuse your plan for the same values, so it isn't quite as painful, I guess, but it's confusing. Why are you using dynamic SQL? What's the point of it? It doesn't really make any sense. I don't know why you're doing it. I'll never know why you're doing it. I'll have to guess. So it's really confusing is what it is. And as anybody here knows, using dynamic SQL for no good reason is very confusing. In general, I would only ever consider using dynamic SQL when it's the appropriate solution to a problem, not for this purpose. Never use it as an optimization tool. Do not use to get rid of sniffing. It's going to definitely make everything more complicated. And if you're trying to write obfuscated code to confuse people, great, but don't do it. So realistically, if you're trying to solve sniffing, this is the wrong solution. It just is because it doesn't make any sense. And I can show you what it looks like because it's ridiculous. It's ridiculous. So here's what I do. I'm going to go ahead and clear out my cache. I'm going to take my proc from earlier and wrap everything in dynamic SQL. Look, hey, I have dynamic SQL here. And I splice in these values. So now every execution of this proc is going to run this query and get a new plan for different values of start and end date. It sounds good, like, oh, I got a new plan. It'll be the right plan, yay. But it's going to generate a lot of plans, is what it's going to do. So now if I go ahead and I run it for a narrow range of values, I get the good plan, a seek. If I run it for a wide range of values, I get a scan. Great. I run it for a range of values that generates no result set, and I get the right execution plan. So at first glance, you'll say, hey, I solved it. It's good. I got all the great plans done. But if this runs millions of times, billions of times, very frequently, then it's going to it's basically recompiling all the time, making new plans. So if you're using lots of different values all the time, you're not just making your optimizer work a whole bunch, and that kind of stinks. So the result here is going to be it's basically behaving like a recompile, and it's going to be expensive. And it's confusing. Any developer is going to come here and look at this and say, why did you do this? And I'm going to try to explain it to them. They're going to look at me funny, and that's not good for your career. Being looked at funny by developers is not good for your career in general. I wouldn't recommend it. So there's that, wrapping in dynamic SQL. Why would you do it? I don't know. I got 3 different plans here, though. You can see I got 3 different execution plans with all different stats. You can view them here and see a seek and see a scan and see a seek just like before. So I got different plans. So my verdict here is just don't do this. It's probably a trap. Not only is it a trap, but it's going to make you look silly because no one's going to know why you did what you did. So, and again, we've all made mistakes before. If you've done it before, I'm not insulting you. Just, going forward, don't do this again. And if you have code out there like this, you can clean it up and make it better. Making code better is always a good thing. We've all made mistakes. That's life for us, really. So here's something a little interesting. You can actually tell a query to optimize for certain parameter values. And this is weird. It's very specific, but it can work. This can be a very good way to solve problems when you have a lot of detailed knowledge about how an app works and how a query works. You really need to know how something works used effectively, though. This can be like, a fine-tuned scalpel to solve a problem, but unless you really know what you're doing, it can run afoul and cause you trouble later. The biggest challenge of query hints is that you put them in your queries, they solve the problem, you walk away to solve the next problem, the next problem, the next problem, and then maybe a month later, 6 months later, a year later, the app changes, and the ways the query runs the way they execute changes, and suddenly your optimized form may not be appropriate anymore. And so this really is a scalpel. You should only use it as a last resort when everything else fails. It could be a temporary solution, like production is blowing up, you put an optimized for in there, now it's working. Great. Or you're the expert and you know precisely how this thing works, and you know this is the right solution for it all the time. If you can say that, go for it. But again, it's not the sort of solution you should spam everywhere, because it will very often be an exception to an exception and not the rule. So use it carefully. I can show how this works. So I'm going to create another proc, and the only difference is going to be I have an option here. I'm going to optimize for this specific set of values. I'm going to optimize for a narrow range of values. So I'm really optimizing this for a seek. I want to seek all the time. That's what I want. I, as a database expert, know that. I will create this proc. I'm trusting myself to do the right thing. And then in production, 99% of the queries look like this. Nice narrow range of values, and it gets the right plan. But then the wide range of values execute, and I get a seek, and 140,000 reads. That was not what I wanted. Now I've been run afoul. This might be okay if this is run once a year and no one cares about it being slow once. That might be fine, but it may not be fine. I run it for other various executions, and I get the same execution plan, and I will always get the same execution plan because I'm optimizing it for this. Now, the data can change in the table, and that might alter how this looks, but this is generally going to result in the same plan. So I'm trying to be smart and do the right thing, and you just got to be sure that you're not trying to outsmart the optimizer and that you really know best. So optimize for will usually be a trap unless you really know what you're doing. That's how I'm going to kind of frame it here, is that you can use it. You can use it in efficient and effective ways, but unless you really know what you're doing, you fully understand the database, the application, all this code, it's probably going to be a trap that comes back to haunt you later. And I kind of say that about all query hints in general. Like, don't use a query hint unless you're sure it's the right thing all the time, or the exceptions are okay. Be careful, because that query hint was going to stay there forever. And forever is a long time. It really is. Here's a cool one. Did you know that you can make temporary stored procedures? I didn't know it for a long time, but you can. You can create a stored procedure with a pound sign in front of it. It's temporary. It'll last for as long as your session lasts, then it goes poof, or until you drop it. And it's kind of a cool way to isolate logic that's temporary in nature. If you don't want to run an ad hoc query, and you want to like have some plan reuse for a little while by an application, this is one way to get plan reuse and a limited lifespan for a proc, and then make it go boom and get rid of it. It's kind of cool. So in general, this performance is the same as a brand new stored proc. You create a brand new proc at the same performance. This is a great way to target specific code where either you know it's very temporary in nature, or it just has known parameter sniffing problems that you've been able to solve through other means. And so this can be kind of a neat way to solve a complicated problem. I don't advocate using this in a lot of places, but it's kind of a cool thing that exists that you may have a legitimate use for. Here it is, a temporary stored procedure. Cool, right? It's kind of cool. I'm going to create the exact same text otherwise. The only difference is I changed DBO into pound sign. Done. Everything else is the same. I'm going to go ahead and create the proc. Now, if I go ahead and run the proc, it just runs like the proc did earlier, right? I get my seek, I get an empty set seek, I get a scan, seek still. Now, just do plan reuse here. My wide range of values here will still generate plan reuse that I may or may not want. It's behaving just like a brand new proc, but it's isolated, right? This proc is isolated from my session right now. Anyone else using my SQL Server here doesn't have access to this. They can't see it. It's in tempdb. It's mine. That's cool. It's a very isolated way to take your logic and put it in one place and know that it won't be used elsewhere. I do not recommend spamming this everywhere, like a lot of suggestions I make, but it's kind of a cool way to isolate logic where you're not sure of a better way to do it. And then if I close my session or drop the proc, it's gone forever. Poof, all gone. So this is a useful technique. I wouldn't recommend using it often. It's a very specific use case, but if you're out of ideas, you want to isolate logic somewhere, this could be a good way to do it. If you see that you're filling up your schema with hundreds and thousands of temporary stored procs, you probably overused an idea, as is often the case with good ideas. But it could be a great way to kind of fix a problem that's very isolated and keep it isolated. So take the bad stuff, put it over here, make it temporary, isolate it, and then all the rest of your code in production, 99.9% of your code, doesn't have to worry about it anymore. Now we're going to go down the rabbit hole, crazy stuff. Trace flag 4136, you can disable parameter sniffing, great, right? I've seen a lot of people do this because, hey, I'm disabling sniffing. Yay, it's gone. The problem's gone forever. But what you're really doing is disabling param reuse, not just sniffing. You're not making sniffing go away. You're making plan reuse as we know it go away. And so now you're kind of optimizing for unknown, which is basically just saying guess. SQL Server, take a wild guess. And we've already established that letting SQL Server do wild guessing may work sometimes. It will not work other times. So it's a server-wide setting. Therefore, if you do this, everybody's affected. You, me, the whole world uses a server. That may not be what you want. Realistically, I'd recommend anything instead of this. Query hint, a database configuration setting, anything to this, because making your whole server do this may not be what you want. Now, again, if you're the expert, it's your server, and no one else uses it, and you know exactly how it's used, you can do this. But in general, I advocate against it because trace flags are kind of like forever, and your uses may change. Somebody may create a brand new database in the future. They may have a new usage pattern, a new app. Who knows? Somebody may connect Tableau one day and say, hey, we love Power BI. We're going to start using Tableau too. Bam. Our whole new workload from this merger is now going to hit the server. Go. And then things perform badly. So in general, this is one of those. If you really know what you're doing, do it, but don't forget about it because it may not always be a good solution. It will affect everything and everybody. Not going to demo it. I don't feel like enabling a trace flag and restarting my services right now. Here's the reality. What generally goes wrong in sniffing kind of falls into two categories. Parameter sniffing is either SQL Server made a goof or we made a goof. And realistically, honestly, most of the time, we made a goof. There is a new feature, the parameter sensitive plan optimization, that addresses these SQL Server goofs. We'll talk about that shortly. But most sniffing traditionally is our fault. I'm just being honest here. That's how it is. You have some crazy logic, some crazy SQL, and it's giving you trouble. What are the biggest reasons why our code fails us? Here's some examples. Number one, the biggie is too many code paths. If you have a stored procedure with code that goes everywhere, if, then, else, switch, go to, while, blah, 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 everywhere, case statements galore, you're basically taking a proc and having lots of units of logic everywhere. And every time you run it, you may not use the same code path. And so you're going to optimize the first time for one code path, but then it may change. And when it changes, you get the same plan. And that plan may not be the right thing. You may have 10 switches for a report, right? And you run it first time with switch number 1. But what happens with switch number 2 through 11 or whatever? Well, I don't know. You have the same plan. Similarly, too many parameters. If your proc has 50 parameters, well, that's a lot of parameters and a lot of values. And there's just more ways to have sniffing because they can all change in unison. How many different combinations of 50 parameters can you have? That's a lot of factorials I don't feel like mathing out right now, but it's a big number. You get a lot of code. You have 10,000, 5,000 lines stored proc or trigger or function or view or something crazy. Like the larger your stuff gets, the more complicated it gets. The more complicated it is, the more the optimizer is going to cry trying to get a plan for you. And the more often that your plan reuse will end up getting something wrong and then reusing the wrong for all the other things that come through. If you have any of these problems, your code is too big, too many code paths, too many parameters, the easiest way to solve it is break your big, big, big problem into smaller problems. Not everyone likes doing this. It can be uncomfortable to take your 5 reports in one and turn it to 5 reports, but it will solve the problem, I promise. So consider ways to break your problem into simpler problems. And don't be afraid to reuse your code. If your one new smaller proc can be used in 5 places, that's fine. That's great. Reuse your code. But having a giant 10,000 line monstrosity is very susceptible to sniffing. Having 50 parameters is susceptible to sniffing. Having crazy code logic paths everywhere, very susceptible to sniffing. If you find that you're hacking your SQL a lot to fix it, you're tweaking it, goofing with it. I changed exist to in, and now it works. Yay. I added an optimize for, I added a recompile, I added no lock, I added blah, 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 blah. If you find you're tweaking and poking and poking and poking, and it gets better, you may really have a bigger problem here, a different problem. That could be your code is stinky and it needs a little bit of attention. Again, if you're tweaking, eventually you should stop and ask, why am I tweaking so much? And will it really be a permanent fix if I keep having to fix it over and over and over? Sometimes we use the wrong tool for the job. We may try to run analytics against a transactional database or vice versa. We may try to use table as a queue, right? You have a table where you have 100 rows that are in flight and being written to, and then a billion rows that sit there and do nothing. That can generate some weird stats that may result in weird plans. String manipulation, another abuse of XML and other kind of things like that. Files in your database, things that make the data size lopsided. If you're using the wrong tool for the job, that may result in weird plans and bad plans and plan reuse that you may not want. So these are all just different ways that you can think about finding problems and fixing them when they're out there in your code. This really is the best solution. Unfortunately, it's also a hardest solution because we go back and fix our bad code. The quick fixes, the hacks, the how to lose 50 pounds in 1 week, whatever, those don't work here. It requires some time and effort, but these are the best solutions, though, is making our code better. And they're long-term solutions. They're not short-term solutions. You fix your crazy proc that has 10,000 lines, it's fixed for everybody forever. And that's nice. Lots of other hacks people do, I wouldn't recommend. You can disable parameter sniffing as a query hint. It's kind of like optimized for unknown. It's kind of the trace flag. It's usually a bad idea. Here is a different hack that may be useful. Optimize for ad hoc workloads. A lot of people spam this blindly, but if you really do have a server where most queries are different and they're all ad hoc and they're never the same thing over and over, what this will do is instead of generating a plan, it'll generate a stub first until the plan is reused. It saves a little bit of resources from a full execution plan being generated. I only recommend it if you have a server where you really do have a lot of ad hoc plans and you can't fix that first. Again, this is a symptom of a different problem. Is you have lots and lots of ad hoc workloads hitting your server. Is there a way to fix that first or not? And if not, maybe this is okay. Again, solving a problem, it isn't really a good hack to have, but it solves a problem. You can set parameterization first in your database. This will attempt to parameterize ad hoc queries that are not normally parameterizable. It can reduce compilations, but you may actually create more sniffing because now you're parameterizing things that were parameterized before. Again, if you have a lot of queries that are parameterizable, but for whatever reason they're not procs, this might help you. But again, a very limited set of times where you'll do this. So be careful. Don't use it all the time. Use it when you think it makes sense. And it's a database config, so you don't have to do it server-wide at least. There are many more hacks out there you can Google. Lots and lots of hacks. They're readily available. I don't have to help you find hacks. But just be caution. Whenever you use anything like this, just make sure it's the right solution. Document it, please, so others know you did it and why you did it. That's very helpful. And then go from there. Query Store is a wonderful tool. If you have it, if it's on, use it. It's a great way to help find regressions or mistakes or problems. Even if you don't have it in production, having it in dev QA can be a great way for testing and verifying new code. Again, this can be used as kind of a tool to kind of document what's going on, what's wrong, what's good. If you had a sniffing issue, this can kind of prove it without having to goof around. This will not remove the need to write good code or build good databases, but it does help with research and validation and finding problems before they are problems. And by default, it's now on, which is kind of cool. It's a good tool. One additional feature that's brand new in 2022 is parameter-sensitive plan optimization. This will basically go and look for scenarios where you have a parameter-sensitive query, and it will try to adjust the execution plans accordingly by creating multiple plans up front, and then having different parameter ranges at runtime that will then result in a different plan being used. This is great for the things generally that SQL Server goofs on. You really want Query Store for this, and it's a very good way to solve non-uniform workloads. This is a great feature. If it's available to you, use it. If it's not available to you, sorry. But I highly recommend using it if you can. A critical key to this feature is it will not fix bad code. If you have a stored procedure that's 10,000 lines long with 50 parameters and go-tos in it, this probably isn't going to help. It might, but it probably won't help. This is really a feature meant to solve where SQL Server makes mistakes most often and try to resolve them. So it's a good feature. I highly recommend testing it before putting it in production, but it's highly recommended. It's good. Use it, but it won't solve your bad code. Sorry. or my bad code or anyone's bad code.
We have
So
another
to kind
question that
oh, go
came
ahead.
in. What is the best way we can identify that it's likely parameter sniffing as query becomes slow, which having multiple reasons?
Okay, where was it? Back here. So a lot of these things are really the symptoms. Do you have too many code paths, too many parameters? Do you have the workload that changes frequently from fast to slow? Is your code long or complicated? Have you tried to hack around it before? I know this is kind of like repeating what I said already, but those really are the ways to kind of identify sniffing and then resolve it. So you're really looking for inconsistencies. But do verify your stats are good first before diving in. But really inconsistency and complex code. And then if this doesn't work, if parameter sensitive plan optimization helps you, if you can use it, you know it's a sniffing issue. If it doesn't help, you're falling back on other solutions that are going to have to kind of work out your code on your own. But there's a lot of ways to find it. Those are some. I'll share all this later so you have it and kind of review it later. I know I talked fast and there's a lot of information here. But again, you feel free to steal this later. I'll share it right afterwards, and you can use this as a reference if you'd like. To kind of wrap up, we can take a few more questions at the end. Plan reuse is a critical part of SQL Server. It's not a bug, it's a feature, and you want to use it as much as you can. You see sniffing as an outlier, as an exception, as an edge case. It does happen. If you run enough queries, eventually you'll have sniffing. It's life. But treat it as an exception and don't change everything to try to solve it. Just try to address the sniffing and move on. That's very important. If you try to reuse one solution everywhere, you're going to create more problems for the future that you're not going to want to solve, or that future other people won't want to solve. And it's going to potentially just lead to uncomfortable situations where someone's going to ask you, why did you do this? And you're going to say, I did it everywhere because ChatGPT said so. And that's not really what you want to say ever. Try to avoid hacks to make problems go away. I totally understand if it's 2 in the morning and things are broken and a hack fixes it. I totally get it. I won't tell you not to do that because sleep is valuable. I believe in sleep. But go back and fix the hack later. Don't leave it. Go back, fix it later, put a permanent solution in place. Don't just leave all the query hints and trace flags and garbage there forever because they may not always be good. Ultimately, fixing business logic and code is really the best way to tackle sniffing. It really is. I know it's a lot of work, it's a hassle, but it really is the best way to tackle it. It's one of the first places you should look to see, why is my code slow? And the good news is every version of SQL Server, this gets better. Plan reuse is getting better. More features and intelligent query processing are addressing this. And you'll find that sniffing will happen less as you get newer and newer versions. It won't solve everything, I promise. This problem is eternal. It will last with us in the future, but it will get a little easier to solve as we have more tools like Query Store and parameter sensitive plan optimization. It will get easier to solve. So with that, I kind of want to turn it over for questions. I'm going to share my information. Feel free to find me, LinkedIn, Twitter, email, whatever. You can bug me. I don't mind. I love hearing from people about their thoughts on my presentation or questions or anything else.
So we don't have any questions at the moment. We'll wait just a second, but really great call out about ChatGPT's deficiency and giving good tech info. I think about, down in the future, how it's really going to propagate bad info the more and more it gets out there. So yeah, to use that with caution, but great call out. Thank you.
Beautiful thing about so go ahead.
Go ahead. No, you go ahead.
A beautiful thing about AI is that AI is only as good as the data underneath it. And that means that all of you data engineers out there and people that validate and QA and move data around, your jobs are very secure. Because if the data you're trying to run AI against is garbage, then the AI is garbage. And so people will always be needed to do that. And will the AI get smart enough to clean its own data? I don't know. It definitely isn't smart enough right now for that. But you got to throw data at it. And it's got to be clean data. So for those of you out there who are in those roles, focus on that as something you do, because that will always be valuable. Nobody can automate machine learning and AI and data science on bad data. You just can't. So that's a huge, important call out, and it's gonna live with us for life. It's not gonna go away. It's been true before. It'll be true forever.
Yep. I know it's some of the things I get returned that's automatic with Google now, and I'm like, nope, I already know that.
Yep, I can do it right now. I can go right now into I can go into Bing right now and just say, like, how do you solve parameter sniffing in SQL Server? And lack of autocomplete should already tell you I got a problem here. Different approaches to correct parameter sniff. You can disable it, but you probably shouldn't. Symptoms of it. Did I write that? Maybe. So we're going to go here to the top article and look into it. What are some solutions? Well, I don't know. Let's see. What are the best solutions to parameter sniffing? What do they recommend? Workarounds with recompile, option recompile, optimize for dummy variables, disable it. I know it's an MS SQL tips. It's a good site, but if I just simply read the first solutions here and do those things, I'm in trouble already. Because again, Google doesn't curate, it just returns results. And so I've already gotten in trouble. And it may be a great article, but if you blindly take what it says, hey, look, look how beautiful this is over here. Bing is telling me use recompile, use local variables. Look at this, guys. Guys, gals, everyone, look.
All the things you
Query
said,
hints, dummy variables. No, Bing, stop responding. Stop. I can't even click stop responding anywhere. It's just like, I'm closing this window now. Sorry. That was fun. We're not going to do that again today. I knew my blood pressure was to come down now.
We had one more question from Young. Does parameter sniffing become bad due to memory grant issues?
It can. I would say not usually. Memory grant issues tend to cause other problems, such as using too much memory or having a spill into TempDB, which will hurt performance. I don't think memory grant problems explicitly will lead to sniffing, but they can be indicative of sniffing or bad stats. Because again, if your stats are way off, it may generate a bad plan and guess the wrong amount of memory to use. I would investigate it. I wouldn't assume that one is correlated or causated to the other, but they might be related. I think that in general, it's a sign of different problems. Memory grant problems are certainly real, and I would try to figure out why you're getting memory grant problem. And on the bright side, 2022 does have memory grant feedback, which can help with that. Another intelligent query processing feature that might help you potentially. I know a lot of IQP is only in enterprise, but it's something just to think about if you have it available, that there is stuff that's addressing that. So correlated, not causated.
And the last super important question, what is your favorite Pokemon?
Oh, my favorite Pokemon is Desert Croc Pokemon Sandile. My family loves everything from, let's see, Bulbasaur to Poplio to Dratini. So there's a favorite family responses in that one too. But
That's
everyone's
some
answer to that
Eevee and
question is different.
Charizard on ours, but I say after the
Nice.
movie, Psyduck was pretty up there for me.
Psyduck. Yeah, we all have to have a little sympathy for that Pokemon. Well, thank you for asking that. That's a great, fun way to end conversation here. I do appreciate it.
Yeah.
Just secretly have a love for it. If you were ever looking in the background, you could probably see some random Pokeballs and things. There's more over here that you can't see. Just kind of adding some flair, I guess, to my life.
Well, thank you so much for taking your time today to share your knowledge. I know a few people that couldn't make it today, and they will really get a lot of use out of the video. So thank you so much for speaking with us today.
Thanks for having me. I'll share everything I have afterwards. And if you need anything else, any questions afterwards, feel free to send people my way.
Fantastic. Thanks so much.
All right. Have a great day, everyone.
You too. Bye.
All right. Bye. That's where we stop.